purple. Okay, so the purple, what do we got? We have the worksheet that's supposed to be due today that we're going over questions to after the homework. That should have been due Friday, but I gave Grace the homework, section 9.6. We need to go over questions to. And then with extra time, we'll be working on the test review. Hold on, all of this is in Google Classroom, true? I think so. I tried to put it in there so you guys could see it. Here we go. The test review I have not due until, that's annoying. It like opens it all up. Wait, why isn't it due until the 21st? Because, hold on, what's tomorrow? The 20th. This is Endeavor Quiz, which means you need to know all of your endeavors from this chapter, so all of the convergence, divergence tests, and absolute versus conditional, that was a card, right? And estimation of alternating series remainder theorem, or whatever combination those words are supposed to go in. Anyway, those three things, which are really a lot more than three things because you have a lot of tests. But those are the three categories of the Endeavor Quiz, which is going to be a fill in the blank. So you don't need to worry about word for word whole tests, me asking that. That's ridiculous. Sound good? Okay. But you need to know all of your Endeavor cards. But then what's the next one? Test part 1. What's the test part 1 like? The worksheet. Test part 1 is kind of like the worksheet, and I'll give you guys a few hints. It could be the remainder estimation thing. It could be find the convergence or divergence of sequences. Literally, does the limit exist? Does it not exist? It could be some multiple choice about convergence. It's the worksheet, basically. Does that make sense? That's tomorrow, which is why the worksheet is due today, so we can go over questions. But what's the next day? What's the 21st? The big list of series, which is like your, not practice test, but test review. Now, if you guys were reading this assignment at all, I said find your 10. What am I saying? Do the entire thing? No. Can you? Yes. On Friday, I talked about the different websites, remember, where you can figure out which ones converge or diverge. But what I said is on your test on Thursday, I'm going to give you not a list of this many. That's kind of overwhelming. But I'm going to give you on Thursday a list of series, more than you need. Okay. On Thursday, I'm going to give you a list of series, more than you need. And all I need to see are 10 that you have solved out. And somewhere in those 10 are used all 10 tests. Does that make sense? Now hold on, if you do something like an alternating series for absolute versus conditional, couldn't you do the alternating series test together with a limit comparison test, maybe together with a, limit comparison, you might have to then do a p-series. Like you could use 3 tests in one. Oh, okay. So can you cheat and make one be worth 3 tests? No. So you can say, hey, that's my alternating. Okay. Then go find a p-series. Then go find a limit. I need 10 series solved. Does that make sense? Why am I telling you that? What can you be using this review as? Literally a practice test. Go find 10.
Is it just going to be this? Like it's just
on Thursday, it's just going to be a list of series. Prove or state the convergence or divergence of 10, making sure that you use or have one series for every single test. But naturally, you're going to be using multiple tests multiple times because of the nature of the convergence divergence test. Justin, I'm sorry. Do you still have a question? Okay. Isa. Thursday. So Thursday will be your notes. Thursday will be your homework spiral. Thursday, because that's the end. That's the end game. Does that make sense, guys? What? I don't. Okay. So to that end, now that we've gone over all the logistics, anybody who's gone, you might want them to watch the video. It might be easier than you explaining it. We need to go over today section 9.6. Let's see if I can get here. Where am I at? Struggle. All right, guys. I want you really quickly in your groups to narrow down questions on the odds 9.6. Okay? Narrow down questions. I just went over logistics. Narrow down questions on the odds 9.6. If anyone has any questions, try to answer. Go. Did I just hear it? I'm terrified. Yeah, anybody gone on Friday? Go grab it. Okay. No one was ready on Friday, which is why we had a work day. And there were so many people gone too. Number 6 should have been C. Number 8, B. Number 10, E. You were just matching sequences to their graphs, to their terms, something or others. Number 52, they give the explanation for 52 that it's a divergent harmonic series. That's just a snazzy name for 1 over n. They're saying, hey, you should know him. He always diverges. But couldn't we also say P series, P equals 1? He diverges. So I guess you could use the definition of this guy, 1 over n. He is a pretty famous one. Or just use P series. 54 is a geometric. And it diverges because what is being raised to the n? 2 pi over 3, which is greater than 1. 6.28-ish over 3. 2/3, that would have been great, but there's that pi in there. So 2 pi over 3 is greater than 1. R is greater than 1. That's a divergent geo. Cool. Number 56. They use limit comparison test to 1 over n. Because 1 over n, the degrees are tied when you do the division, aka multiplied by the reciprocal. And remember, if the limit is equal to a constant greater than 0, what one does, the other does. So since 1 over n diverges, the whole thing diverges. That could be limit comparison. Yes, you're using like a P series in the midst of it, but this could be like your limit comparison test, right? Number 58, converges. And actually, couldn't you have just done P series? Huh, why would you do a limit comparison? That's weird. I would have just pulled the 10/3 out, because it's a constant, and then 1 over n to the 3 halves, P is greater than 1. That's weird. I would have just done P series. But they, what if you already had a P series on your test? Couldn't you do limit comparison and be like, oh, I'll compare to a P series. Hey, look. I mean, it's a way. It's annoying, but it's a way. Number 60, nth term test. The limit is infinity of a sub n, right? Top wins. Ooh, nth term test. What else could you have done? I don't know. I guess you could have compared. Nope, because that would have been infinity and a convergent. Ugh. You could have compared. Whisper. You could have compared to 1 over n, which is divergent, because then if you multiply by n, like there'd be like a little n power kind of left over, but it's, anyway, the limit would be infinity. I guess you could have done a limit comparison with 1 over n, because he'll just keep on winning. I don't know. That's awkward. Nth term is the best way. Number 64, you can't do nth term because the limit is 0. We know nothing, but you could do. Ooh, I'm looking integral test, but I'm not sure I'd want to. Well, because the limit is 0, you know nothing. You could do limit comparison. We know nothing. How would you do that? You're doing some sort of magic. That's not good at 0. But your test is wrong. So you just had your 50% chance of converge diverge, right? The way they did it, because you can't compare to 1 over n squared or else that entire denominator goes away. ln wins infinity with a convergent. But you could do 1 over n to something a little bit less than n squared. That way you have n to some sort of power on the denominator, which will win over ln. The limit will be 0. So they showed a direct comparison, but I think it would have been easier to do limit comparison, but 1 over n to the 3 halves because then you would have had a little bit of an n left over, and that would have beat the ln when you took the limit. I'm just showing quick, shortcut way, but long story short, comparing to 1 over n to the 3 halves, you get the limit equal to 0 with a convergent, hence it converges. I think you're able to do integral test with that one, because I think we've seen ln of n over n squared before. And it worked. What was your u? Did you use integration by parts? Okay. I think I would have done, I was thinking ln of n over n to be dv, but I think you would just make u your ln, right, Kathy? U your ln, dv your 1 over n squared, yeah. That's like, hey, last test, chapter 9, we had an ln of x over, anyway. Go team, that's it. All right, guys, do you have any extra ones for us to add to our questions beyond 33, 43, and 61? Anything to add beyond 33, 43, and 61? Evens or odds? No, you're good. Maggie agrees.
My thing was, there was a question for 9.1 about monotonic and bounded, and I don't know, I copied.
Monotonic just means strictly increasing or strictly decreasing.
And then
Bounded means basically convergent, I think. Because unbounded will be, well, sine and cosine are bounded, and yet dne. I could go peek at that one real fast. But these ones are from 9.6, right? These ones? And then 59 is the one that you're curious about? Okay. That's okay. 29? Okay. Kiddos, if this isn't specifically helpful to you, you have plenty to be working on. True? Okay. So 29, 33, 43, 61. What do we got? Let's start with section 9.6 stuff, and then we'll go back. So starting with number 29. Oh, there's writing in my book. Whose book was this? Let's call someone out. Nixon. Well, is that his writing? I don't think that's Nixon's writing, so it's someone else. Anyway, man, that was a long time ago. Okay. Bloop, bloop, bloop. 29, 33, 43. Let me go grab 29. You guys are good until I start talking, and then I'll start not being so good. But go ahead, take a little bit of time if you're, oh, hey, 33, I have them ready. Don't have 29 ready, though. Lo siento. Okay. Yeah. 29, 33, did I have 43? No, but I do have 60, which I bet is like 61. Okay, so let's go ahead and go steal 43. Putnam exam challenge, that's fun. Where's 43? We just deal with them in separate, or not separate, in different ways. Because this is the end of the convergence divergence. Now we just apply it. Let's get 61 right here. Where's 61? There you are. Oh, cosine of n over n. Got it. Over 3 to the n. Well, it's not like 60. Oh well. All right, cool kids. I'm guessing most of these, the directions are just tests for convergence or divergence, right? Let's start with number 29, and then I'm going to 33, and then 43, and then 61. Then we'll peek back if we need to. Number 29. Aha. Ooh. Root test. Why? What are the conditions for the ratio root test? Isn't there an if? Oh, we had to use ratio? Oh, all right. Limit as n goes to infinity of 6 to the n plus 1 all over n plus 1 would be n plus 2, right? To the n plus 1 times 6 to the n over n plus 1 to the n. I'm going to rewrite a few things just because it helps me a little bit. So I can make this 6 times 6 to the n. I can make this n plus 2, because there's an extra one, times n plus 2 to the n, times n plus 1 to the n all over 6 to the n. Okay, limit as n goes to infinity. I can reduce my 6 to the n. 6 is just a constant, forget him. N plus 2 to the n versus n plus 1 to the n. What I see, do you remember, guys, when we were doing limits with, like, I don't know, x plus 4 to the 5th power, we never actually multiplied that out. We just kind of figured out what the highest term, like the highest degree term would be. Do you guys see how this would, whenever this is expanded, n to the n would be the highest degree term? Does that make sense? And this one would also be n to the n plus a lot of other stuff. So what's true about the highest degree part of this and the highest degree part of that? Tied, except what additional does this guy have? This guy doesn't just have n to the n, he'd also need to be multiplied by this binomial, which would actually give yet another. So this guy's overall degree is going to be n to the n plus 1, whereas that one's just n to the n. Long story short, who wins, top or bottom? Bottom. So you have an n to the n there, an n to the n there. He has an extra n, fine. Bottom wins, therefore my limit is 0. 0 is, ooh, ratio test. Less than 1, true? Long story short, series converges. Is that good? 50. Oh, sorry, number 33 also says to use the ratio test. Except it's an alternator. Now, ratio test says positive terms, or no?
Yeah, it does. Wait, let me look. Let me just make sure. I'm pretty sure it does say positive.
Yeah, remember to study this for tomorrow anyway. Ratio root test. Maggie's looking at the if. I think it should be the...
Yeah, it says a series that has a positive term.
Okay. So... limit as n goes to infinity. I'm going to look at absolute convergence then, because that's all I can really test. So I'm going to consider, I'm hoping it's absolutely convergent, or else it's going to be not so fun. I'm going to consider the absolute value. Okay. I'm considering the absolute value, because if I can show absolute convergence, I don't have to do the alternating test. So with this guy, the limit as n goes to infinity, since I took out the alternator, I'm allowed to do the ratio test, n plus 1 factorial. Now this one's going to be a little bit rough. Or maybe it's not, because if I plug in an n plus 1, do you guys see how I'm going to have 2n plus 1, but I'm going to have an additional 2n plus 2 plus 1, 2n plus 3? Because you would have to plug in n plus 1 here, the 2 would distribute, 2n plus 3. So it goes one term past, which is really nice when comparing, because when we compare, we have the 1, 3, 5. All of that's going to cancel up to the 2n plus 1. But this guy will have that little extra 2n plus 3 remaining. And remember, this guy is going to be 1 to n plus 1 all over 2n plus 3 times n factorial. That's going to reduce with all of that. So therefore, I end up the 1 to the n factorial. Additional n plus 1, additional 2n plus 3. My limit is 1/2, which is less than 1. Therefore, since the absolute value converges, what do I know about the alternator? Does that make sense? Because I considered the absolute value. Because I couldn't do ratio test with the alternator. I considered the absolute value, so I was looking for absolute convergence. Thank goodness it ended up converging, because otherwise I'd be like, I don't know, let's go do the alternating series test, not with the ratio test. I don't know what to do. That one was pretty nasty, unless you realize, take the absolute value and then consider. 43. Root test. Please tell me they didn't say you had to do ratio. Okay, good. For the root test, only positive terms. The limit as n goes to infinity. Guys, if you notice, this is not a fraction. So not doing, doing ratio test is not going to be very helpful. I don't have a fraction to compare to. So degrees of top and bottom is gross. But I can do this whole thing to the 1 over n. That's what my root test says, right? So the n to the 1 over n ends up just reducing out. I have the limit as n goes to infinity of 2, the nth root of n plus 1.
Yeah, and then that's where I got stuck.
Do we?
It's infinity, but apparently there was like on CalcBC like some weird explanation.
Yes.
So why? So like that stuff. I don't know. I was just like, I got infinity just by looking at it. But
Well, we have a special converging sequence. The only dilemma is that's when n goes to 0, not infinity. So what they ended up having to do was go back to the old-fashioned limits that we had to do once upon a time that were nasty when you had to use ln. That's how we got to e with the definition of 1 plus x over n all to the nth. We had to use ln. So what they did is they basically pulled out the 2, the limit as n goes to infinity of n to the 1 over n. Because 2 times anything, we can pull that out of everything, no big deal.
why can't we use special convergence?
Because it's going to 0, not infinity. The special converging sequence is n goes to infinity of n to the 1 over n. I think.
I think it's infinity.
Is it infinity?
I think I'm tripping. I'm pretty sure it's infinity.
Oh, it might be. I was thinking it was n going to 0. 0 to the infinity.
Yeah, I got infinity.
Oh, never mind.
And it equals 1. So 1 plus 1, that's 2.
So 2 plus 1 is 3. Yeah?
Does it converge? What's the answer?
Well, no, careful. This is the ratio test. 3 is greater than 1. Therefore, we should have divergence.
Oh my gosh. Turn up. That was good.
Never mind. Praise the Lord for the special converging sequences. Hey, someone who asked me on Friday, Ari, was it you? Special converging sequences, do you think maybe we should review those?
Yeah, those are so nice.
Because otherwise you'd have to use ln, which I was totally ready to do. I was like, guys, remember, n to the 1 over n. Let's do ln. Let's do ln. Let's pop down. Let's just delete that whole page and say, hey, we have those special converging sequences. Number 61. Ooh. Does cosine go between 1 and negative 1? Yes, but does it hit other fractions in between? Yes. Now, hold on, pause. If you ever see a cosine of pi n, wouldn't this be cosine of pi, cosine of 2 pi, cosine of 3 pi? Wouldn't that be things like negative 1, 1, negative 1? I could say this guy is just an alternator, but why can I not say that cosine is just an alternator? Cosine of 1 is 1 radian. It's in the first quadrant somewhere. It's a fraction. Cosine of 2 is in the second quadrant somewhere. It's a fraction. Ugh. So I can't say he's an alternator. But what can I do? Well, the limit as n goes to infinity is 0, which tells us nothing. So maybe we shouldn't do the nth term test. We could think of... Ooh. I was thinking of the limit comparison test of 1 over 3 to the n. But the problem is when we do that, actually the 3 to the n's cancel. My limit cosine or make up his mind. My limit does not exist, so that doesn't really tell me anything. But can't I say this is always less than or equal to 1 over 3 to the n? Will cosine ever get bigger than 1? Is this a great direct comparison test one? I'm not guaranteeing on the test there will be one like this, but if there's a cosine of n or sine of n, use direct comparison, because don't you always know he's less than 1? Right, not good. BC, the class that you're in, but also if you have a bigger converging sequence, what by the direct comparison test? Pause. Is this great for the test? I will give you full points on Thursday. No. But do you know the idea? Give me a few more words and you'll be good. Yes. Like geo to 1/3, right? And then you can just say something about direct comparison, because remember, you have to tell me what test you're using it for. direct comparison test, BC, bigger converges, N converges. That's good. I'll take it. Because it gives me all the pertinent information. It gives me what test, it gives me bigger converges than the smaller converges. And you're telling me, oh, hey, by the way, I knew he was convergent because he's a geo. Maggie.
I'm sorry, can you just clarify one more time? Yeah, so because cosine's on top, it bounds or it finds the, so like anything basically is going to be bigger than it? Like if I compare it?
Well, these to be similar or else you're in trouble as far as denominators. But you can, it's going to be bounded by 1 because it goes between 1 and negative 1. Does that make sense? So 1 is going to be an upper bound to cosine because of the squeeze theorem, like how we can say cosine of x is in between. I know that cosine's always less than 1, less than or equal to 1. Yeah.
Because of the denominator or because of cosine?
Because of cosine. Yeah, because the denominators are the same. So everything put aside, it'd be the exact same, except cosine is doing this forever, like confusion. Usually less than. Every now and then he hits this, but otherwise he's less.
Okay, got it.
The nice thing is direct comparison test. It's less than or equal to. Not just less than. Okay. Whew. Last call. Section 9.6 questions. Going once. Going twice. Sold. Now we're going to the worksheet. Let me pull it up really quickly on Google Classroom just so it's easier for me to check. Yeah.
I have a general question about telescoping.
Yes.
Could we review it really quickly? Or could I just ask you a question?
Well, I can, guys, here's a good practice. Actually, I've already looked at the worksheet. Has anybody found any telescoping? It's good. Has anybody found any telescoping on the worksheet? Okay, so what else do we have? The review. How do we, because this is good for the test on Thursday, or maybe tomorrow, probably Thursday. How do we find telescoping typically? Partial fractions, typically. Partial fractions meaning some sort of binomial in the denominator. I was looking at 30. No, that's not good. 17. Oh, I hadn't gotten to him. Perfect. 17. I like it. 36. No, that's going to be a... don't do that. Number 17. Is that the one you were asking about? Good. This is technically on the... Let me just get rid of this page. You guys didn't have that question. There we go. Technically on the test review, but telescoping is a good idea that would probably be more like... Yeah, because that's one of your tests, right?
Can we use this one on the packet?
Yep. No. It's okay. How do we do partial fractions? Can we review that first? Now, guys, you could go ahead and plug in, and that'd be 1 over 1 times 2 is 1/2. 1 over 2 times 3 is 1/6. 1 over 3 times 4 is 12. Ooh, what is this pattern? 1 times 2, 2 times 3, 3 times 4. Oh, no, that's right. Okay. You might not see much of a pattern there, but if you were to actually n and something over n plus 1, anybody doing the heavy side cover-up method? Yeah. So now if I go expanding, I get 1 over 1. Well, I want a little more room. Telescoping, remember, just Ariane was asking about it. We want to see what remains. So when I plug in, I get 1. Remember, it's not always the same thing, minus 1/2. And then I have plus 1/2 minus 1/3. Then I get plus 1/3 minus 1/4. Do you guys see some telescoping? I do. 1 over n minus 1 over n plus 1. I see the 1/2s canceling, the 1/4. I'm going to come up to, if you guys notice, the first cancels, then the second. That one will have canceled from before. This one is remaining. I'm taking the limit as n goes to infinity of 1 minus 1 over n plus 1. That's going to be 0. Converges, and doesn't just converge, converges to 1.
my question was, in the forever card, it says when you're, like, if it converges and you're finding the sum, then you do, like, the limit of n to, like, b of n plus 1. What is the plus 1?
So it's in almost every partial fraction, you have, in almost every, there's some weird ones where you might have a couple pieces remaining and then a couple pieces. This guy would have canceled out first before that guy, so this would have been our secondary piece. So it kind of depends on the telescoping. But we're trying to see, up to this point, who's still here. Well, if I stopped here, the 1/2 cancels, but he's still there. If I stop here, the 1/3 just canceled, but he's still here. If I get up to here, he's just canceled, but he's still here. So basically we're saying, okay, what's stuck at the beginning, what's stuck at the end, and then that pattern will continue forever. So take the limit as n goes to infinity of that little stuck part, and will it converge?
So why is it plus 1? Like
Because plus 1 indicates usually the plus 1th component, or it could be plus 2, it could be plus 3. It depends on your partial fractions and what your denominator is. But usually that secondary piece is the one that you're taking the limit of. But when we were going over the card, I did that example. I did the example to prove to you after that one that was a very basic, straightforward, this one. I did the example saying it's not so much I want you to memorize that, I want you to have the idea down because there might be is left over. Something else, the n minus 2 might be canceling and this might be your piece. So the n plus first just means basically when you get to the nth term, what piece is remaining, take the limit of that with your other components and see if it converges. Yeah. Okay, worksheet. I know you guys had some questions. I'm going to start with if there's something to do with estimation remainder. Because that's one that we haven't gone over recently, and I know it is on there tomorrow. Nothing about error on this page?
Yeah, I did geos. You can separate this out, like 2 to the n times 2 to the negative 1, and the 2 just goes up top.
All right, guys, just because class is about to end, I hear you guys working a lot on stuff, which is really good, but I did hear a question about estimation remainder, and it is on test part 1 tomorrow. So I'm going back in our notes really quickly to where we talked about that, just to review really quickly, okay? Estimation remainder, if I were you, I'd be listening because some people just said it's not on your review, okay? Remember how we did a couple examples? And the couple examples could have gone a couple different ways. One way is find the 5th partial sum or the 10th or the 7th or whatever, nth partial sum, and tell me the error bound. Remember, whatever S sub n is, alternating series, the error of this partial sum will be less than or equal to the next term, whatever it is, right? So if I give you some sort of partial sum with a certain established n, just go one more, and that's going to be the error. But how does it get tricky? What if they say, okay, I'm not going to tell you who n is. You figure out n to make it within. Or we did another example to make it within. Then what we have to do is say, okay, we need the a sub n plus 1. Take your a sub n. Take your a sub n. Plug in n plus 1 to the term and say, okay, if they want you within 1,000th, if they want you within 0.005 was what? 1/200th. I'm going to go ahead and say the expression, the n plus first term has to be less than that expression, that error. And then you would solve, solve, solve. And remember, if you get greater than 9, choose 10. If you get less than whatever, choose the one below. Usually it should be greater than or lower the error would get. But just be careful, watch out for your sequence. And guys, if it says less than, that means not or equal to. If it says within, you are allowed to equal. So we do have good examples, great examples of the estimation remainder. Yeah, please do. We have great examples. Mm-hmm. Ugh, I haven't done that recently. Okay. Yeah. I think I just need to copy and paste from last year. Do we need anything different? Oh, our numbering was different. That's why yeah. Guys, I'll be here today until 3:45. Some of you need to study sesh at some point. I think the trickiest thing tomorrow will just be having your tests all ironed out for the Endeavor quiz, having the convergence, divergence tests and all the endeavors ironed out, and then the remainder. I think that's the trickiest part of tomorrow. Otherwise, multiple choice like worksheet. Thursday is the one that's going to be a bit of a beast if you don't prepare for it now. Cool? Yeah. All right. If we have extra time tomorrow, we'll review some more. I doubt we will, though. So whether you're coming in 0 period asking questions, whether you're coming in 7th period after school asking questions, I'll be available. Bye, guys.
So when we come in, if we come